If the first thing that we want to do when you see this equation is to just multiply this out and combine all the terms and you go from there, well, I will tell you it's not going to be too easy because we'll be ending up with way too many terms. So I wanted to show you guys a much cleverer way to solve this. Check this out. Notice that we have x plus 1 and x minus 5 in the parentheses. In fact, we can take advantage of that. Why? Because the middle of plus 1 and plus 3, well, that's the answer. The middle of plus 1 and plus 5 is just the same as plus 3. 1 plus 5 divided by 2. So I'm actually going to do a substitution, let's say y, to be the middle, which is x plus 3. Now, if you look at x plus 1, you can look at this and then just minus 2 to both sides, and that's how we can get x, 3 minus 2, which is plus 1. That will be the same as y minus 2. Come back here and say y minus 2, and we will still have to raise that to the fourth power. Similarly, for that, y is equal to x plus 3. I will have to add 2 to both sides. So that's how we can get x plus 5 to be y plus 2. So now, this is y plus 2 to the fourth power. And I guarantee you, this is going to be easier compared to the original one if you expand it. We still do have to expand the fourth power though. But the advantage is that you have the minus 2 and then plus 2. There will be a lot of terms that will cancel each other out. Now, the question is, how can we expand the fourth power? Well, the answer is you can use the binomials theorem, and to remember the binomial coefficients, you can use the Pascal's triangle, and this is how we do it. You start with 1, and then you go like 1, 1. So far, so good. Next, you still have 1. It's all ones like this, all ones like that. To get the next number, you do this plus that, 1 plus 1, which is 2, and then, yeah, and then the last number here is 1. If you're dealing with the fourth power, you want to end up with 4, so check this out. 1, remember, start with 1 all ones like this. 1 plus 2 is 3, and then 2 plus 1 is 3, and then 1. And then do it again. 1, and then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. Goes like this. I see a 4 right here. This is what we need. We are going to use this rule for the binomial coefficients. Okay, so let me show you guys how to do it right here. Y minus 2 to the fourth power. Start with the coefficient 1, and then I will take this, which is y, and then raise that to the fourth power, and there will be no 2's. Next, that will depend on how you want to do it, because this right here is a minus, so you have to alternate the signs. The first term is positive, the next term will be a negative. So it's a minus. Write down the coefficient here, which is 4. And each time the power of y will go down. So we will have y to the third power. But the power of 2 will go up. So it's 2 to the first power. Now, things have already accounted for the negative right here. So I'm looking at this as a 2 to the first power instead of negative. It's not negative to the first power. If you put negative 2 to the first power, then this would be a plus. So it depends how you want to do it. Anyways, continue. Next, we have this coefficient, which is 6. The power of y goes down by 1, so y squared. And the power of 2 goes up by 1, so it's 2 squared. Continue. Positive, negative, positive. The next one is negative. And the coefficient is 4. And then y down 1, so it's y to the first power. And then up 1, so it's 2 cubed. And lastly, plus the last coefficient is 1. Y to the 0 is just no y, which doesn't matter. And then 2 to the fourth power. So that's how you do it. And if you expand this right here, well, we will end up with y to the fourth power. 2 times negative 4, so it's negative 8 y cubed. And then this is 4 times 6, which is 24 y squared. And then that's 8, that's 4, so it's 32 minus, and that's 16, so plus 16. So this right here is for that. And of course, we still have to do this right here. And since it's a plus, that means all the terms are plus and the numbers are the same. So I'm just going to add y to the 4 plus 8y cubed plus 24 y squared plus 32y. I know you see it, right? And then plus 16. So this is that, and all of them together will be 32. Magic. Anyways, now notice if you add them up, well, all of this right here will just be 2y to the fourth, and this and that cancel, which is very nice, and that's plus, well, what I'm going to do is instead of just adding them up, I'm going to factor out the 2 because this and that are the same. So it's 2 times these terms, right? I'm just going to cancel this out. 2 times this, so 24y squared, and then plus 16. Right? 2 times that, and that's equal to 32. Now, 2 times this quantity is equal to 32. I can just divide both sides by 2. Very nice, huh? So divide this by 2, divide this by 2. So we are going to have y to the fourth power plus 24y squared plus 16, and that's the same as 16. And then subtract 16 to both sides. We have y to the fourth plus 24y squared. It's equal to 0. And now this is very nice to solve, right? We can factor out y squared. And then we get y squared plus 24. It's equal to 0. And this right here, that means y squared is equal to 0. Or y squared plus 24. It's equal to 0. To solve for this, that means y is equal to 0, and y is x plus 3, so x plus 3 is equal to 0. So that means our first answer, x is equal to -3. And in fact, this is a double root because we have the square here. So it's actually -3 and then another -3. Now, for this right here, I'm just going to subtract this 24 to both sides. So y squared is equal to -24. And then take the square roots to both sides, put a plus or minus, cancel this. Then we will have y is equal to plus or minus. We have a negative inside of the square root, so we have an I. And then 24 is the same as 4 times 6. Square root of 4 is a regular 2. So we have a 2 here, and then still square root of 6, like this. Now, y is x plus 3. And that's equal to plus or minus 2i square root of 6. Subtract 3 to both sides. X is equal to -3 plus or minus 2i square root of 6. And then we are done. Pretty cool, huh?